Hey y'all, and welcome to your online notes. This is day one. We're talking about multiplying and dividing monomials today. To start off, I want to talk about exponents here. So we have 2 squared and 2 cubed. Just to review, if you have a calculator, you can type this in using 2. There, a lot of your calculators will have this x squared button that will automatically square the number that you're using. But say we want to go to cubed. Well, then we don't want the square, so we'll do 2x to the y, which you see we get this little caret, and we'll go to the third power, and then we get 8. So you're either going to have this x to the y, or you'll have a little caret button that looks like that, and you'll click that to put in exponents into your calculator. Now that we got that covered, let's go ahead and go over some essential vocabulary. A monomial is an algebraic expression consisting of one term. So that term can be a number by itself, like 3. It can be any variable, like let's say x. It can be any combination of these, like 3x, 3x squared, 3xy. All of these are monomials. A polynomial is when we have more than one term. So if I have 3x plus 2. That's called a polynomial, and we're not dealing with those right now. We're just talking about these with their single terms with the monomials. Some other essential vocabulary that we're going to get into today is product of powers, where we're multiplying two powers that have the same base, and the quotient of powers, dividing two powers that have the same base. We're going to see this a little bit more, but just remember, if we have something with an exponent, this is our exponent, and this is our base. That is important to remember for today's lesson. Let's go ahead and get into some examples. So we see our first two examples with product of powers. Let's go ahead and the directions on these will be simplify using our laws of exponents. So one of our laws of exponents is when we're multiplying two things of the same base. Well, if I have 5 squared times 5, what am I really saying? I'm saying 5 times 5, that comes from that 5 squared, and then we still have that times 5. I wrote a 2 there. I meant to write a 5 there. Whoops. Let's go ahead and erase that 2, make it a 5. So we really have 5 cubed, or 5 times 5 times 5. What we really did here was, if I gave this as an exponent of 1, because everything has an exponent of 1, I really took this 2, added that 1, and I got that 3. Well, let's go ahead and look at a different example and make sure that this rule stays true. So if I have c cubed times c to the 5th power, well, what's this saying? Well, c cubed is saying c times c times c, and we're multiplying that times c5, which is 5 c's. So we have c times c times c times c times c. Man, that's a mouthful. So how many c's do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8. So that's really saying c to the 8th power. Well, how did I get that 8? Well, I just added that 3 plus that 5. So our tentative rule here then would be, if we have two bases, two exponents with the same base, we could add their exponents when we're multiplying them. So why don't you go ahead and try those two problems. Pause the video right now and try to solve those two problems, and hit continue on the video, and then we'll go over your responses there. So what you should have gotten is, to that 9 to the 3rd power times 9 to the 2nd power, we would have gotten 9 to the 5th power. So we have 9 times 9 times 9, 5 times. And with that a to the 3rd power and that a to the 2nd power, my a's kind of look like my 9's, I apologize, that would get us a to the 5th power, because we're just adding these two exponents together when we're multiplying two things of the same base. But what if we don't have the same base? Well, let's take a look at a more complex problem right here. We have negative 3x squared All right, so I'm going to write that down. Negative 3x squared times 4 to the x to the 5th power. So this time we have some coefficients we have to deal with. Well, all we're going to do when we have coefficients in front of in our monomials is we're going to multiply them across regularly. So negative 3 times a 4 gives me a negative 12. Well, now I took care of this negative 3, I took care of this 4, they're no longer problems. Now I just have x squared times x to the 5th power. Well, these have the same base. They're both x. So I can just, this is saying x times x, and this is saying x times itself 5 times. So if I can just simplify that by adding this 2 and that 5 to get x to the 7th power. So simplifying using the laws of exponents, I added my two exponents with the same base, and I just multiplied my coefficients normally to get negative 12 x to the 7th. You go ahead and try it on this problem. Remember, you're just multiplying the coefficients regularly and then using your laws of exponents for those variables. And remember that everything has an exponent of 1 if it doesn't say anything. Hopefully you've solved this problem. You should get 16m to the 6th. If you got 16m to the 5th, keep watching because I'm going to show you what you probably got tripped up on. So we have a negative 2m times a negative 8m to the 5th power. I just rewrote this problem to look like the problems we've seen so far. So I'm going to take care of these coefficients first. Negative 2 times negative 8 is a positive 16. And what I can't forget, what's so important and why I reminded you, is this m to the nothing isn't m to the 0th power. It's not, because anything to the 0th power equals to 1, and m isn't equal to 1. We don't know that. So it's m to the 1st power. There's one m there. So what's 1 plus 5? Well, it's 6. So we have m to the 6th, which is how we get 16m to the 6th power. Hopefully that makes sense. Let's go ahead and move on to our next practice problem. Before our next problem, be sure to write this down in your notes. If you are multiplying two powers with the same base, that's very important. They have to have the same base or else this doesn't work. You can add the exponents. That's very important. Go ahead and jot that down in your notes if you haven't done so already. Let's take a look at the quotient rules. Well, if we're multiplying and we add them together, what do you think we're going to do when we're dividing? Hopefully, you said subtract, because that's exactly what we're going to do. I see that I have two bases that are the same, 4 and 4. Now I'm not dividing 4 divided by 4. I'm saying 4 times 4 times 4 8 times divided by 4 times 4. Now I can cross cancel these, but then I have all these 4's left over on the top, which is why we can just subtract these. To get 4 to the 6th power would be how I simplify using my laws of exponents. And then you can even work out 4 to the 6th power with your calculator. But just to show you what we're doing, I'm saying 4 times 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 4. That's 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 to the 8th power. And we have 4 times 4 here on the bottom. So if I cross cancel that 4 with this 4, that 4 with this 4, what am I left with? I'm left with 1, 2, 3, 4, 5, 6 4's being multiplied together, which is exactly what we have, which is why this works. So this n to the 9th power over n to the 4th power, this is saying n times n times n 9 times. This is saying n times n times n 4 times. Well, if I divide out 4, then I'm just subtracting that 4 from that 9 to get n to the 5th power. We'll have 5 n's being multiplied together left over after we divide it out. Go ahead and try your luck on those two problems. The answers to those two problems are x to the 7th power for the first one, because 10 minus 3 is 7, and 5 to the 3rd power, or 5 times 5 times 5, which is equal to 125. Hopefully you got that. But Mr. Emnon, what if we have a bunch of different types of problems? Well, we still follow our same rules. So don't be scared when you see this problem where we have our multiplication and our division. We're just going to take it one step at a time. So we have 2 to the 5th power times 3 to the 5th power times 7th to the 5th power all over 2 to the 2nd power times 3 to the 4th power times 5. Alright, well let's just take a little look on how we're going to solve this problem. So let's just take this one at a time. So I have 2 to the 5th power and 2 to the 2nd power. Well, both of these have the same base of 2, so I can subtract their exponents. I can subtract that 5 and that 2 to get 2 to the 3rd power. Since I took the 5 from the 2, that's going to be on top of my fraction here. So I have 3 to the 5th and 3 to the 4th. Well, 5 minus 4 is just 3 to the 1st power, which is just 3. And then I have 7 to the 5th power. Well, there's nothing I can really cancel out with that 7 to the 5th power, so I'm just going to keep it the same as 7 to the 5th power. And that 5 stays right down below. And then we can go ahead and calculate this out. So if you were going to calculate this out, which you should, because that would be the simplest form, we have 2 cubed, which gives us 8. So we have 8 times 3 times 7 to the 5th power. 7 to the 5th power, that's going to be our large number here. So we have 7 to the 5th power. Ooh, baby, that's a big number. We're going to multiply that by 3. And we're going to multiply that by 8. And we have that huge number, but we can't forget this divided by 5 on our bottom of our denominator. So we're going to divide by 5. So our final answer for the simplification of this was you could write out this. That's a simplification. Or 80,673.6. Both of those are simplified. We will tell you if we want just the number or the written account of this. But this leads us to our rule. When you're dividing two powers with the same base, you can subtract the exponents. Go ahead and give your shot on those two. They all have same bases that cancel out nicely, so it shouldn't be too bad. Go ahead and pause the video, try those on your notes, and we'll double check it here in a second. So for that first one, you have 3 to the 4th, 3 to the 2nd, so you should get 3 to the 2nd times 5 times 7 squared, because remember that 5 has a 1 there, or 2,205. For the next one, you have 5 to the 6th and 5 to the 4th, which gives you a 5 to the 2nd, minus 7 to the 2nd, times 7 to the 2nd, times 8, or 9,800. So those are examples that we'll go through in class. Your assignment is on Schoology. It is problems just like this with multiplication and division. Feel free to take another look at those examples if you need to see them. But hopefully this helps. If you have any questions, please send me an email. I'm more than happy to help. Have a wonderful day. I'll see you all later.